So for today's lesson, we are really going to focus on the rationalizing and the conjugate method, but I did want to give you one of these problems to go over. So again, with every limit problem, we're going to try to plug in first. And so when we do that here, again, we're going to get 0 over 0, which means something can be factored out or simplified. But when you see a fraction in a fraction, the best first step is to try to simplify that. I do that in a method where I cross multiply. So I'm going to have this x on top, that's from the numerator. And then I have x minus 4 plus 4 over, and then you multiply these two. So 4 times x minus 4. And so what you can see here, and usually when you simplify these, what you'll start to see is that whatever's causing the problem, right? And in this case, because x equals 0, it's this x up here and some random x down the bottom. They will cancel out. And so I'm going to keep the x from the numerator. I see these 4's cancel each other out. And so now I have x over x minus 4. When we have division of a denominator, we're going to flip that up, and so we have x from the numerator times 4 times x minus 4 over x. And there we see them cancel out, which is great because that means we're ready to take the limit. And so we have the limit as x approaches 0 of 4 times x minus 4, which happens to be negative 16. Now, it's my hope that you guys practice B. It's very similar to A, except for now you're simplifying in the numerator. But again, we're probably still looking for this x to cancel out, because when we plug in, you can see already we're going to get 0 over 0. All right, so that's the first problem on your list to try. But let's go to the next one. The next problems involve what we call the rationalization technique or the conjugate method. The technique of rationalizing can be used to find the limit where there's a radical in the numerator or the denominator. And so here we see the graph of the square root of x plus 1 minus 1 over x plus 1. And so what you see, and we can see right at 1 there's a hole, which would mean that the limit exists. And we can also see that when we plug in, we're going to get 0 over 0. So in this case, what you're going to do is you're going to take the top and the bottom and multiply it by what we call the conjugate of the term involving the radical. So we're going to multiply this by x plus 2 plus 1. So we see the sign change. And that really gives us difference of two squares, which will cancel out the radical. Times, and we're really actually only multiplying it by 1. It's a pretty neat method. All right, so in order to simplify this, multiply the term. So when you have x plus 2 times x plus 2, you're going to get an x plus 2. And we choose difference of two squares because there's no middle term. And now all you have to do is subtract 1. Now the bottom, I want you to leave it alone. So again, we're always looking for what's going to make this bottom problem go away. So we got x plus 1 times the square root of x plus 2 plus 1. What you're going to finish simplifying, when we simplify the top, we have the limit as x approaches negative 1. So this simplifies to x plus 1, which is perfect. We're going to get that to cancel out, and we're going to have the limit as 1 over x plus 2 plus 1. Plug in negative 1, and I believe we're going to get a half, which is right where it looks like this hole is. Okay, so then the rest of your homework for today is to finish B. I think that should be